This lesson we talk about the physical characteristic of an inductor. We use a simplest inductor to explain the basic concept. We learn a formula to calculate the inductance of this simplest inductor, and then we have one example to show how to apply this formula. The figure here shows the simplest inductor. As you can see, there is a rod in the center. After bending this long wire and wrap it around the rod, it makes n numbers of coils. If you measure the length of the coil, not the length of the rod, the length of the coil, it is L. And we need one more thing. That's the cross-sectional area of the coil. In the picture here, it is same as this area. Overall, to find the inductance of this inductor, we need to know the number of turns, the length of the coil, and the cross-sectional area of the coil. Let's look at this formula here. Inductance is N squared mu times the cross-sectional area divided by L. So what's the information we can get from this formula? The formula shows the inductance depends a lot on the number of the turns. It also depends on the cross-sectional area. The bigger the area, higher inductance. Smaller the area, small inductance. And it's inverse proportional to the length of the coil. The longer length decreases the inductance. A short length increases inductance. In addition to these quantities, the inductance also depends on one more thing. That is the material made of this inductor. It is the mu, that permeability. Permeability is a number that shows how good this material can be used to make inductor. A bigger permeability value indicates this is a good material for making inductor. A small permeability number shows this is not a good material to design inductor. How about let's work on one example to see how to apply this formula. For the example, we need to determine the inductance of the coil below, this inductor. The permeability of the coil is this value, 0.33 times 10 to the power negative 3 Henry per meter. The length is 2.5 centimeter, and the radius of the core is 0.05 centimeter. There are a total of 400 turns. We have all the information we need. We are ready to solve the problem. Given N, the number of turns, equal to 400 turns. The permeability equals to 0.33 times 10 to the power negative 3 Henry per meter. The radius of that cross-sectional area, that circle, equals to 0.5 centimeter. How about let's convert these to meter, equals to 0.5 times 10 to the power negative 2 meter. And the length equals to 2.5 centimeter, which is 2.5 times 10 to the power negative 2 meter. Because radius equals to 0.5 times 10 to the power negative 2 meter, let's find the area. Area is pi r squared. It is pi times 0.5 times 10 to the power negative 2 meters squared. Using calculator, I get 78.54 times 10 to the power negative 6 meter squared. So now we can use the formula to find the inductance. Inductance L equals to N squared times mu times the cross-sectional area divided by the length of the coils. This equals to 400 squared times 0.33 times 10 to the power negative 3 Henry per meter times the area, which is 78.54 times 10 to the power negative 6 meter squared. And then divided by 2.5 times 10 to the power negative 2 meter. Using calculator, I got 165.88 millihenry.